Hello and welcome to lecture 9 of Introduction to Probability and Statistics. My name is Skunbut Ek Vityanipon and I'm gonna teach you about normal distribution. For that's kind of a typo. That should not be the standard one. It's about all the normal distributions. Anyway, let's get right to it. So last time we look at the clip and see the phenomenon where if you have the garden board, the board where you drop balls and make them, spread, it's gonna form a nice curve all the time, almost all the time. So we are gonna look into details on what is that nice curve doing right there and how to get some meaningful, computations or meaningful outcomes out of it. So first of all, the normal distribution have, if you remember it, we have two main variables, the mu and the sigma. Mu is the mean or the average, or in this case it is the center of the graph, and sigma is the standard deviation or the spread of the curve. But since if mu and sigma can take any value, then it's gonna be like confusing to study. So here at first we are gonna focus on like 3/4 of the class. We're gonna focus on the case when mu is 0 and sigma is 1. Mu is 0, sigma is 1. And hopefully for other values of sigma and mu, we can deduce the case from this standard case. So here the standard normal distribution. Sorry about warp text there. But yeah, we are still talking about a random variable. But now we use the letter z instead of x because not sure why, but yeah, let's use z. So now z is the, again we still have to define z as something that we measure. Like maybe c is the height, or c is the weight, or c is the temperature, or something. But once we define that and when we plot the nice continuous probability distribution function, then we get the graph here, and this graph has properties that the mean mu is 1. Oh, it has 3 properties actually. First, they are normal. We define normal as the weird function, which you don't have to worry about that. So it has to be a normal distribution. It has to be that function, and that function, it means it's this kind of curve. It has to be that kind of function. It has to have the mu the mean of 0, and it must have the standard deviation of 1. And so it's normal, mu is 1, and the sigma is 1. And instead of having to write this whole sentence, we abbreviate that as this using this notation. So z and this similar notation is what we used before. Right, so we are saying that z, whatever z we define in the first place, follows this distribution. The behavior of that random variable is this distribution. This letter stands for normal. Then we have mu and sigma as 0 and 1. So if you suggest z is similar to n of 0 and 1, then what you have at first here is, we have that nice curve, and whatever we are going to do with that curve is what is going to be discussed later. But once we have that distribution, just like the continuous distribution, just like the the constant one, or the triangle one, or the exponential one, or whatever. Once we have that curve, we can ask questions about the probabilities under the curve. The probability that the values is less than some value, is greater than some value, or is between two different values. And the way the way we could find that is by using the integration. So we have to integrate that nightmare function with e to that something square. Right. In theory, you have to integrate that function, but in practice, we can't. You can if you're brave enough, but we can't. So we have to we need help from other tools. So yeah, the curve will look like that. It's not gonna be exactly that. I think it is cool. Should be something like that. But anyway, it's gonna look like that. The center is 0. Right. Sigma is 1. Sigma is not hard to see here, but you will see sigma in one moment. And sigma is 1. It should look like something like that. So if let's say if I give you this curve, if I don't tell you what it is. If I ask you to compute the probability that x, if that z is between -2 and 1, then you should be able to identify that, oh, my task is to compute the area under this curve between these two endpoints from -2 to 1. But then I use the same color. But anyway, whatever the result is, whatever the area is, then that is what the question is asking. Right. The next question is, how can we compute that? The answer is no, you can't. That's why you need to use some tools. The tool people used before is this kind of table, the Z table. If you Google the Z table now, you get this kind of like nice marriage table looking table. Right. This is what we used to use. We used to have when even like 30 years ago, 20 years ago, people used that. And then yeah, because that table is so large that you have to like squint your eye and see the tiny rows, the tiny entry of that table. Like let me give you some example here to use this table. For example, if I want to find the probability that z is less than, let's say, -1.2. This means I look at this table and find the entry of -1.2 here. Let's say -1.25. -1.2 is here, and I have to find it 0.05. 0.05 is up there. So that probability corresponds to the value in this table. If I make sure I'm looking at the right row and make sure I'm looking at the right column, that will give you 0.1056. So you can say that it's approximately 0.1056. So this table represents all the areas, all the areas under the curve where z is less than that specific values. Because usually you would have to use the integration to find the area, but since like most of the question it's gonna be about z is less than some values up to 2 decimal places, then why don't we just have the values for all of these frequently used random variables, and you can find all the values. Like if it's like -0.09, you have to look at -0.0. Have to look at 0.09. Make sure you bring your glasses to the class or something like that. But that was good old days. Nowadays we can. That's what people back in there. However, there's an app for that. So let me introduce you to this app. Yeah, I don't have. If you click on the try it button there, then that will bring you to a new tab with the app. Yeah, I should have prepared that, so you don't have to wait for me to. Okay, there it is. Okay, there's an app for that. So before we use the app, let's see what does it have here. So we are talking about the normal distribution, x similar to n of mu and sigma. Yeah, that's what we justify. We define the s as a z because z is the standard one. But for any normal distribution, we use an x, and still the same n. We can plot a graph for any mu, any mean, and any sigma, any standard deviation, and then you put the sigma, mu and sigma right there. For the standard normal distribution, we put mu to be 0 and sigma to be 1. Oh, and let me start from scratch. If there's nothing there, you put mu equals to 0, you put sigma equals to 1, and there it is. That's gonna give you the curve that we are looking for. So now the next question is we want to find, areas under this curve from, in this case we are going to find the area where the random variable x, capital X, is less than a specific x. So let me put x equals to -1. No, x equals to -1. And the funny thing is you have to move your mouse outside the box, and there it is. First, it shows you the area, the corresponding area for that type of question, for that type of probability. So if we want x to be less than x or x to be less than 1, then we first set the point -1 here, and then we compute the area to the left of that point, and that gives you us the value of 0.15x. That means this red area is approximately 1.15x, and of course the decimal keeps repeating to the right. It's not just like these 5 exact decimal places, but as for an approximation, that number is good enough. This one, yeah, you get that value. If we change that to be, let's say 3, or let's say 2. So that means we first look at the point 2, and we find the area. We find the probability that x, capital X, is less than 2. So it's from that point, move to the left. Now we are looking at, we want to compute the area, the red area, and the answer from this app is 0.97725. And that kind of makes sense because that it seems like the red part is almost like eating the whole curve. It's just only this tiny area that is not computed. The red seems like it is getting almost all the entire curve. So it makes sense to get a value that is close to 1. If you change it to 3, right? You see it's 0.99865. 3 is something here which you can see, and I don't think you can zoom. You can see the tiny blue part here, but oops, that's too small. Yeah, nevertheless, you look at the point 3, you compute the area to the left, and then that gives you 0.99865, which is close to 1. And you can have that kind of question, or you can look at the right part and say, oh, that's not visible. But if I set x to 1, and if I want to find the probability that x is at least 1, then that will be the area to the right of that point. Okay, so we compute the area and get 0.1586, and then you just can keep changing values. And -1, get that area is -2, you get that area. And so that's one of the standard type of questions you would get asked. You see that they also have two more type of probability. So let's use that. Okay, so this is asking for the probability that the capital X, the random variable, falls in between 2 values. And those values are the absolute value of x, and so it says 2. So the absolute value of x and the minus of absolute value of x. So if x is 2, then absolute value of x is 2, the right part, and the left part is the minus of that value, so it's -2. So it's between plus and minus of the same value, and that's what you get here. So it's the area between these 2 values. And the result is 0.95. Again, it looks large enough, so it makes sense if that's close to 1. If I change x to 0, you get a smaller area, a smaller range, but still it's from -1 to 1. If we put even like 0.2, it's even smaller, and the number is now decreasing to about 0.2 each. So that's the normal distribution. That's the type of questions you might be interested in. And the reason why you might be interested in this area, because if the center or the mean represents majority of people or majority of the value of the measurement, then this area will represent the ratio or the amount of people that is not too far from the average, that is close to the average. And here is 0, so the average is 0. So that's one, and then the last one is the third one is computing 2 times phi of x is less least absolute value of x, which I don't actually have to explain. If put in the value of 1 and see how this looks, and it should be natural that what kind of question this is asking. It's asking the opposite questions. So instead of asking for the area between 2 values, it's asking for the areas outside of those 2 values. And outside here means away from the center. And so it's to the left of the left part and to the right of the right part, where this left and right part are symmetric. Meaning that if we change that to 2, it's finding the right and left part too. And this also represents the question we commonly ask, which is we are looking at the percentage of people or of the population where the values are too far from the center, too strange, or let me see that way. So if you know that, let's say that's the height, let's say 120. If you think that the average of of all the heights of people is 120, then if x is, let's say, 172, it doesn't. Oh, that sucks. Anyway, this has to be 0, I guess. Yeah, so it's looking at the values that are too far from the center, both on the right and on the left, and find the total area of those areas, of those parts. And if you want to look into more information, you see the values down here. So the mu and sigma are actually given there, so that's gonna be the same values. The nice thing is they specify that mu is e of x, the expected value of x, and sigma is the standard deviation, and the variance is sigma squared. Then you can click the help, and if you click that, the FBI agents will come to your house and rescue you. Hopefully not. If you click that, then you can read the full description of what this function is trying to do, and also how to use that. If you forgot what I just said in class, you can go there and read what are the blue and the pink areas trying to represent. Yes, that function that we just saw, the nightmare function. So anyway, that's the thing. So you don't have, instead of using the table, you can use this app, and it's totally okay if you use this app in exams or homework or whatever. But if I ask you to compute this by hand or to compute this using a specific method, then you're supposed to use that method. Or if I ask you to find the probability that x is less than 5, then you just use this app. It says 1. It's not exact, but okay, that's the app. There's an app for that. Use it. Any other app you have at hand. Okay. And the type of problems we will encounter are these 3 questions, where you notify the probability that z is less than b, or greater than b, or between a and b. And by the way, there's no single z table. I'm saying it's a z table, but there are actually 2 or 3 variations, depending on you want that table to represent the probability where z is between 0 and a, or you want that table to represent the probability where z is at most a. That means we also counts the cases where z is negative. So there is no one z table. So if you want to compute values of this type, if we are given one of these values, we can compute kind of like the rest using some properties. And those properties are, first we have to use the usual property, which is the totality of probability distribution function. This means that whenever you see a curve and you want to compute the area to the left, that area to the left is 1 minus the area to the right. Or in other words, those two areas add up to 1. And that means if you want to find that the product that z is less than b, then that's going to be 1 minus the probability that z is at least b. At least b. Notice that I use the less than on both, because again, let me remind you that it doesn't matter if you use the less than or equals, because it is impossible to get z exactly equals a anyway. And so it doesn't matter if you remove that point from the graph. So that's one property to use. The second property is the symmetry. The symmetry. So, but symmetry, it means the area to the left and to the right are the same. So if you want to find the probability that's let's say here, that z is less than minus 1, right? So from this question you see that that area is represented by the area to the left here. And most of the time we don't like negative numbers. That's like not nice. So we prefer to use the positive numbers. So here you can change from this kind of questions to the positive part, if that is one. Then if you look at that in the mirror where you reflect the whole curve along this line, the center line, then that part is gonna be exactly that part. Just like move that to the other side. That means the area here, the probability that z is less than minus 1 is equal to the probability that z is at least 1 is greater than 1. And then we can easily change those values from 1 to any values. So the probability z is less than a is equals to the probability z is at least minus a. And here the thing is, a doesn't have to be negative or positive. Here I'm showing you the case when z is negative. But what happens is if z is positive, so what if we want to find the area to the left of this point? Let's say z is less than 1. We can still use the reflection, use the symmetry. Because once you reflect that in the mirror, then you reflect that point 1 to the point minus 1, and from the area to the left of that point to the area to the right of that point. So those two areas are still the same in the mirror. So that is equal to the probability that z is at most 1, at least 1, less than 1 is equal to the probability that z is greater than minus 1. Just by flipping the mirror. We have those two things. And finally, the third one, which is also frequently used, is like 1 plus 2. What happens if we use those two packs together? So first we see that the whole area is 1. Second, we see that the area to the left and to the right have to be equal. If you use both two, that means if you want to find the probability that z is less than 0, which is this part here, right? That's gonna be equal to the probability that z is at least 0, z is greater than 0, the right part here. Okay. But since we know that the sum of these two are 1, these two areas is equals to 1, and those two are the same, so we can rewrite. Let's say we can rewrite that as let me do this way. We can rewrite this as p of z greater than or greater than 0. Yes, still equals to 1. You're just changing from that to that, and that it's just twice the value of p of c at least 0. So it's 2 times that equals to 1. Or in other words, p of that is 1/2 or 0.5. So what this is saying is the area to the left of the center or of 0 is equal to 0.5, as well as the area to the right of that curve is also 0.5. Maybe that is obvious, but once you see the problems in, it's not obvious anymore. So we have to use your experiences to solve this kind of questions. So there are 2 things, right? To totality, to make sure you remember that the whole thing has to be 1. Second, you have to see that it's symmetric. The left and the right are the same. And the third one is the area to the left and area to the right are equals. And they are equal to 0.5 or 1/2. Right. Using these 3 properties, we can compute most of the questions about the probability. So first, of course, you can use the F. You can use the F if you actually have to in later classes. But for now, the question is gonna be of type of given one area. Can you deduce the areas? Can you deduce the outer areas? Using the properties and using your analysis on the curve. So for example, if I give you that the area between 0 and actually that about half an hour. So let's finish this here and start the example in the next clip.